Well, I'll tell you what, while we're waiting for the rest of the folks to come in, I'd like to just have a call out to say Soraya and Alex, who I see there. You guys wave. They are, I'm going to spotlight you for just a second. Hello. These guys are helping me with the technical stuff and the chat and Q&A. Hey, thank you guys so much. And Soraya just joined my Field Arts Institute Exploring Overland as our new, what are we calling you, Soraya? You're like going to be my main product development person and just
development associate, I think.
Yeah, all sorts of great things. Soraya is an artist.
Hello, everyone.
Welcome. All right, so let's see. Take you guys up here and thank you. All right, well, I'm going to go ahead and get started. So good morning, everyone. I'm Roseanne Hanson. Welcome to Weather 101. We are going to geek out today on learning all about weather and the difference between weather and climate and all sorts of great things to add to enhance your nature journaling and field notebook practice. All right, now the way we're going to work today is I'm going to do a presentation, and it will start with defining things and introducing different types of clouds and things. I still hear someone is not muted, so we will, Alex and Soraya, if you can help find people in the list and mute them, please. Thank you. And so we will get definitions and learn an awful lot about clouds and then how to forecast weather. And then we're going to transition to looking at different ways to record that in your journals and also practice a little bit with some blue colors and creating clouds, different ways to create clouds, which is always fun. And then we're going to create cloud charts. I'm going to do a different couple of demonstrations so that you can put these in your journal and help identify your clouds. So if you've just joined us, we are asking folks to please turn off their video and make sure you're muted. We've got a lot of folks who haven't muted, so please check your mutes. Thank you so much. All right, I think that's it, everybody. We are recording this. I will be posting this probably tomorrow evening on my website. So also Alex and Soraya will be sharing links with you, a link about the, with a lot of the information, tons of the information that I'm going to be sharing. So you don't have to write everything down. And then you'll be able to pay more attention and have fun. So with that, I think I will get started. All right, and let me know if there's anything weird happens. All right, welcome everyone. I'm Roseanne Hanson. I am the Art and Science Program Coordinator at the University of Arizona's Desert Laboratory on Tumamoc Hill, which is one of the world's oldest field laboratories, and was founded by Andrew Carnegie in 1907. And I also have my own Field Arts Institute at exploringoverland.com. I've been a naturalist, an author, writer, and keeping field notebooks for well over 35, 37 years. And I also wrote a book called Nature Journaling for a Wild Life, which is kind of an 8-week course on how to get started doing this wonderful activity that we all enjoy. So welcome everyone and to Weather 101. So you guys who know me, I get teased a lot because of I'm known as kind of the metadata queen. So why is weather important to record? It's all about the data. And I always like to say there are two basic types of data to record in our journals. One is metadata, and then everything else, which is what I call nature data, what you're observing, the plants, animals, and observations like that. So what is metadata? It is the data that supports everything else. So putting the metadata in your journal is really important. It supports your nature data. And that metadata comprises position, your position in time and in space and time. Where are you? What time is it? What date is it? So position, then condition, what's going on in the weather, the atmospheric conditions, the oceanic conditions. So position, condition, and context. What is happening locally? Let's take a look at what this looks like. You can see there's a lot of little shorthand on my field journals. This is how I do start every single page. And people develop their own ways and record whatever they want, and you kind of develop this on your own. But what's the point of all this? So there's my position, the date, the time, location, the latitude, the longitude, the elevation. So that's the 32 degrees north, 111 degrees west, 2,691 feet, and what the date is. Sometimes I put the time, sometimes I don't. The condition, so that's the weather. Cloud cover, cloud types. So there I wrote calm, cirrus clouds. We'll be talking about these symbols later, but these symbols represent the metadata of weather. So wind speed, if there had been wind, then the sun and moon rise, moonset, sunset, and the temperatures. And then finally, the context. I always write a little bit about what's going on. How do we start? What's going on around me? It's a sense of the current phenology, the seasonal natural phenomena, especially in relation to climate and plant and animal life. That's really a huge part of what nature journaling and taking field notes is. Here it is on some more pages. Again, position in time and space. Here's the conditions, the weather. So on one, it was 100% cover. You can see the little symbol for that. I'll have a chart to share with you for that. What are the clouds? There's cumulus clouds on the one. Full moon, really just everything I can. And then the context. It was full overcast and another storm moving in. The wind was picking up and the temperature was lowering, and this was at 5:50 p.m. Or the fact that we got rain, which in Arizona, you guys might laugh, like 0.3, you think that's a lot? Well, it is right now. And 0.03 is worth noting as well. And interesting that was like kind of the first pandemic entry I did in 2020. All right, so how do we get that metadata? Well, I'm going to show you some ways you can figure out stuff kind of naturally and kind of cool, but you can also use your phone and use apps, the sunrise, sunset. I like sun and moon, tide alert, my radar, Gaia GPS. These are all great apps for finding your metadata, your location, your weather, your tides if you're by the ocean, and so forth. All right, this sounds, like, well, what is weather? But we kind of need to define it. It is the state of the atmosphere, literally, describing more or less the degree to which it is hot or cold. Is it wet or dry, raining, snow, calm, stormy, clear, etc. And I thought it was interesting just kind of looking that up, that the other two definitions of weather are opposite of each other, kind of. To weather can mean to wear away, something degrades, or you can weather something safely through, like you weather a storm or you weather difficult times. Just interesting little nerdly stuff. But what's the difference between weather and climate? So climate is the aggregate weather conditions over time in an area. Or, it could be a long period, it could be just the season. And you can see from the chart there, those are the classifications of climate zones worldwide. So the red are the deserts. You've got the polar regions, or the dark gray brown. You've got tropics or blue, and then everything in between. So those are our climate classifications. But back to weather, because that's what this is about. So where does weather happen? In the atmosphere. And the atmosphere is this thin sheet of air extending from the surface of the Earth to the edge of space. And it's about 60 miles thick. And in this photo, which was taken from the space shuttle, it's that blue band. And it's not uniform. The fluid properties within it, which we're going to look at, are constantly changing with time and location. So that's weather. And that occurs just in a relatively tiny band in the troposphere. It's about 4 to 12 miles thick. And that is where our weather happens. So what drives weather, and this is all really high level stuff. I can't give you guys 100% like deep dive into all this stuff. And people take years and PhDs to learn a lot of this stuff. So this is all very high level, very just to get you going. And so you understand cloud development too. Tropical and temperate regions receive more sun, yes, and that warms the air. And so that air rises as it warms. And then as it gets to the top of the troposphere, which is the top called the tropopause, it starts to cool again, and then it starts sinking. And these create vortices, which creates our 4 jet streams. There are 2 in the northern hemisphere and 2 in the southern hemisphere. They travel east, and they also shift in the winter and summer, and that drives weather. So let's take a look at what they look like here. So there's the polar jet stream and the subtropical jet stream, both in the north and south there. And they're literally like tubes of air zooming around the planet, 140 miles per hour, more or less in the center, and then kind of grading out to 80 miles per hour around the outside of this tube. So it literally is a stream of air moving around the planet, four different ones. All right, stepping back again a little bit. You would be tempted to think that when you talk about where clouds form, that it's the same all over the planet, but actually they form at different altitudes once you start getting into the different latitudes. So here in the temperate regions, there are low, mid, and high cloud forming regions. And here, like from up to about 6,500 feet is what we call low classification. Up to about 16,000 feet is mid. And then it's kind of looks like they're saying there's kind of up to 16 to 23 is also mid to high. And then the high portion is up to 45,000 feet. But at the tropics, there's more air, goes even higher, 60,000 feet. And in the polar regions, it's a little shorter ceiling, 25,000 feet. So this is what we're going to be focusing on, are these low, mid, and high altitude regions where clouds and weather form. And if you're going to be doing a cloud chart, do take note where you are on the planet, and you might need to adjust your altitudes a little bit. Clouds form when air is cooling. So in our atmosphere, the rising air cools and sinking air warms. And the clouds that you see most likely are caused by rising air. And that can be, when wind hits a mountain and goes up, or it can be literally atmospheric pressure that changes and makes air rise or sink. And also say when cold air or air gets colder for other reasons, say there's warm air and it hits a patch of cold water, that can create weather as well. And clouds known as fog. Or when it hit like warmish air, it goes over a snowpack, something like that. Okay, and then we're going to be, this actually, there's only 4 ways really, basically, that the clouds are classified. So you can get the high level cloud types in just 4 basic steps. So the first way clouds are classified is how high are they in the sky, the low, mid, high. Whether they are made up of ice crystals or water droplets that haven't frozen. Their general appearance, literally. So we'll look at that in a minute. And finally, whether they are producing precipitation. Okay, so here's a chart that I put together. And the types. So by appearance, puffy clouds, literally just, cotton ball puffy clouds, are cumulus. It's abbreviated CU, and the prefix is cumulo, and they occur at low, mid, and high altitudes. Another appearance is whether they're forming layers, and those are called stratus clouds, abbreviated ST, and with the prefix strato. So you can have stratus clouds, but then we're going to look at when we would use strato. And they also occur at low, mid, and high altitudes. Then if they're formed from ice crystals or contain ice crystals, they are cirrus clouds. And those only form in the high altitudes. And cirro is the prefix, or CI abbreviation. And then if it's producing rain, the clouds are called nimbus or nimbo. And then here's the one like weird, confusing thing. Clouds are also sometimes named or classified by their location. And there's only one word that's used for that, and that's alto. But we all know, if you know Spanish, alto is high, but it's not high, it's mid. So alto something is mid altitude. So let's look at some of these. So here's a cumulus cloud, puffy, at low altitude. This photo is taken from our desert property. We have a off-the-grid property. We actually lived there for over 10 years. It's solar and wind powered, and it's out in southwestern Arizona, out toward Babaquiviri Peak, which is that peak there. You'll see quite a few photos from our Raven Rock property. So that's a low altitude cumulus. Here's mid-altitude cumulus, again, puffy. And then here's a high-altitude cumulus, big, puffy, getting tall. Here is both low and mid stratus clouds. So when they're down low fog on the ground, and then mid-altitude stratus. And then here's what cirrus clouds look like. That's a high altitude, of course. And then we often need to combine the various cloud terms to accurately describe them. So there's lots of different combinations. I'm going to just do the high level ones. And if you really want to get nerdly, there's wonderful organizations like the Cloud Appreciation Society and some other cool groups that you can learn all the other nomenclature that can be attached to clouds. But let's look at the basics. Puffy clouds are called cumulus, as we know, but here is a layer of cumulus clouds. So that's when you start adding those prefixes, stratocumulus. So that's a layer of cumulus clouds. And if those puffy cumulus clouds start building up high in the sky and releasing rain, That is cumulonimbus. So literally cumulus clouds that are raining, cumulonimbus. These are cumulonimbus clouds. These are altocumulus clouds. So these are puffy clouds, but they're high up, and they're also stratocumulus because they're forming a layer. So there's a mix in there of altocumulus higher up where they're separated, and then stratocumulus. But you can use the word broken when they're kind of mixed up like that too. And then these are cirrocumulus clouds at high altitude. They're puffy cirrus clouds. You can see that in their makeup there. It's a really beautiful, really cool looking cloud bank. All right, I was talking earlier about how Tucson's had some interesting weather recently, and this is unusual for June, early June, to even have clouds in the sky. But these are called cumulus fractus. You can see that was a cumulus cloud formed, and then because it was windy, it started blowing apart. And so that's called cumulus fractus. So there's loads of cool names like that that you can start learning. And then there's other cool clouds too. These are kind of like specialty clouds. Oh yeah, well, we talked about fog. If you've ever been in fog, you've been inside a cloud, a stratus cloud. Lenticularis, or lenticular clouds, are lens-shaped. They're created when there's a lot of like uplift, like over this canyon, Grand Canyon. Thank you, Jan. I think you're here today. Jan Schwartz took this photo at the Grand Canyon. They look like UFOs, and they're literally formed by really crazy wind currents. Really cool looking. There are mammatus clouds. They're ice particle pouches on the bottom of clouds that sink because they're into the drier air, usually near thunderstorms. And literally, you know, the mammatus, the mammary, yes, it's the same word origin. And I just had to include this because this is a super cool name. Asperitas have well-defined wave-like structures on the underside of the clouds, but they're chaotic. They're not like the mammatus. Really must be like really intense clouds. Another cool term is virga. We get that here in the American Southwest. It's probably get it in other deserts as well. Wisps of precipitation that don't reach the ground. So you just see these waves and then they just sort of disappear. Those are called virga. And maybe you've heard a mackerel sky, which looks like fish scales. And those are cirrocumulus or altocumulus clouds that look like it's a very rippling, even pattern. Really beautiful. And then my new favorite, noctilucent clouds, which means night shining. This is a photo from Mars. This is iridescent carbon dioxide, which is dry ice, clouds on Mars that are mother of pearl luminescent. I mean, how cool is that? We actually can get noctilucent clouds here on Earth too, but not carbon dioxide clouds. All right, some other like just things you can wonder. So why are clouds white, first of all? But to answer that, first we have to look at why is the sky blue? And I forgot to mute my phone, so sorry. So blue light. So when light comes into the atmosphere from the sun, it's got all the wavelengths. We can see there the visible spectrum from blue to red. When it hits the atmosphere, it scatters easily in the blue spectrum. So it makes the sky look blue because of all the scattered blue wavelength light. So clouds, that light goes into the clouds, but then it rescatters them within all the water particles, and it appears white again because there's an even scatter within the cloud. So it's got all the colors back in there again. So it's really interesting. You're not actually seeing white, you're seeing light. But what about gray clouds? Again, you're not really seeing gray. You're seeing the fact that light is normally scattered upwards in clouds or to the sides. And that makes the tops appear whiter, which receive less light. So it's more like a shadow than actual substance. And the rain clouds that are like ready to rain look a lot darker because the water scatters more light and even less light reaches the base. So again, that is why clouds are gray or white. It's the scatter of the light. All right, now, reading the weather. Who else is a Lord of the Rings nerd when Legolas says the stars are veiled, something stirs in the east, a sleepless malice. So Legolas was seeing probably Altocirrus or Stratocirrus covering the sky, but we don't need to tell him that. So how do we read weather? Like so many other things, like the tracking workshop I did a few weeks ago, it's about learning to observe and gaining knowledge about animal behaviors, observable phenomena that will trigger or mean something in changing weather. So it's an education. You're going to educate yourself in natural history for weather. And we're going to talk about some of those things, the animal behaviors and the different changes. So in general, very, very in general, early mornings and late nights tend to be calm. And in general, again, because there's exceptions to everything, afternoons are more volatile because, of course, the days had a chance to heat up with all the sunlight coming in and the increased heat. What happens? We saw this, air rises. And that starts circulating things. So it's like an engine driving that. So think of the sun as generating energy, of course, to create weather. So you also want to watch the barometric pressure for changes. So a rising barometer reading, a higher number, in general means fair weather. The air is more stable at the land surface. And then if the barometric pressure is falling, they say, a low barometric reading, that can mean stormy or windy weather. Air starts moving up in the atmosphere. And we're going to look at this a little more deeply because that way you can help understand yourself what's going on weather-wise. So highs and lows. Let's look at low pressure first, the L. Low pressure creates a situation where air rises. As it rises, it cools. And when air cools, it condenses, forming clouds and precipitation. So that's why there's often stormy weather associated with low pressure areas. So you can see there, the bottom right, the low pressure creates air rising. And then as it cools, it condenses and forms clouds. And in high pressure situations, air spreads away from a high. And then, so it's being pushed out. That means, it's left, something's going to take its place, which is the air above. So air above sinks into the high pressure zone, and that warms the air. And basically, clouds tend to evaporate in that situation. And that's why fair weather is associated with high pressure. All right, so general cloud tips, like what certain clouds can mean. And again, this is general, it's not the rule by any means, but cirrus clouds can indicate high or low pressure systems and a more continuous veil that, or a halo around the sun, can also mean a weather change. So that's what Legolas was seeing. The stars were veiled. Stratus clouds, if scattered and white or continuous but transparent, rain is probably not imminent. But if they're aggregating, darkening, possible rain and increased winds. So that's often associated with moist, warm fronts and low pressure. And then cumulus clouds, if they're growing, darkening, it's probably low pressure conditions creating stormy cumulonimbus clouds, which we call thunderheads, which we're hoping to get lots of coming up this summer in Tucson because we're way behind on rain. Okay, so reading the weather and observations of natural phenomena around you and animals, what are some things we can look for? So plants can alert you to rain on the way. Phenols in creosote bushes are a really good example. They start being released more when humidity rises. And that's a really signature desert scent. So that's one thing. You can learn what other types of things go on in your area. So a change in the wind, say you're by a lake or ocean and it's calm, and by late morning you start seeing, even though maybe it's not even windy where you are, but suddenly the surface of the water, you're seeing ripples coming toward you. Well, that could mean there's wind coming on the way. So look for signs of changes around you. And lots of animals. There's tons of lore on this, but it's traditional ecological knowledge too. A lot of it that is true. There's a lot of sayings that, like, if birds start, hunkering down, well, weather's on the way. Well, there's some real science behind that. It could mean a storm is imminent because low atmospheric pressure means less dense air. It's much harder to fly for birds in less dense air. They need dense air for lift. So they're not going to waste energy heading out into a storm. It's also like they could get blown way out of the region. So that's another reason. So there's loads of great things like this to learn about. I mean, some of it's not true, but Farmer's Almanac, right? That's been around forever. It has some really interesting lore. You do have to check the science though. All right, so we'll be pausing for questions between sessions. So I'll take some questions toward the end before we start drawing, and we can clarify anything then, because I'll be getting through some things here. So let's practice reading weather based on this general knowledge that we now have. So remember this photo. We're going to look now. Remember, we identified our position and condition, right? The metadata. We've noted that in our nature journals, our field notebooks. Okay, so my position is 8 a.m. Tucson, Arizona, May 29th. This condition was, so it's morning. There were already cumulus clouds in the sky, which was, does that mean rain? But it was windy, it started to get really windy. It's hot, and the barometer is rising. So that created this altocumulus clouds becoming fractus. Fractus means they're kind of being broken apart. So what really happened the rest of the day? Storms did not develop. They got blown out. The pressure was rising, windy. The conditions were wrong for development of storms. All right, let's look at position and condition here. Central Poland, by a lake, summer, June 1st. Not very much wind movement, just 2 to 5 miles an hour, 65 degrees at 8 in the morning, and there's already altocumulus. The barometric pressure is falling. What do you think? Possible rain? Yes. Often when you start seeing cumulus that aren't being blown out and your pressure's falling in the morning, then you probably are going to get rain by the afternoon. What's this? So position and condition, 8 a.m., Lake Michigan, February 1st, winter, but it's calm, not super cold, 45 degrees, 8 a.m. Barometer's falling though. Cirrostratus clouds are causing a halo around the sun. Indeed, there's a winter storm moving in. It's not there yet, but this is a precursor. Again, you want to look at position, condition, barometric pressure. All right, here's another one. Position and condition. It's 10:45 in Tucson on June 7th. The wind is from the south, 5 to 10 miles an hour. It's 92 degrees at 10:45. Barometric pressure is falling slightly. But these are cirrus and cirrostratus clouds. Does that mean weather? I'm not sure, but let's take a closer look. Because if I turn slightly, this is the same sky, there's a halo around the sun. I was like, whoa, maybe there really is weather coming. But let's look at these conditions a little more closely. The barometric pressure is falling slightly, but humidity has been going down. There's not a build in humidity. And then there's a magic number we look at here, especially called the dew point, which is an index for when precipitation can occur given all the other parameters. So in this case, it was clearing by afternoon, continued breezy and hot. And that dew point here needs to be 55 degrees at least 3 days in a row for our monsoon season to officially begin. So, and especially with the humidity going down, that's just not going to happen. How about this one? It's 6 a.m. in Maine on the coast, September 1st. The wind is mild. It's 65 degrees early in the morning, and the barometric pressure is falling. Stratocumulus clouds in the morning and a bright red, blood red sky. And that usually indicates weather is coming. Now, I bet some people are already saying, red sky at night, sailor's delight, red sky in morning, sailor's warning. So we're going to look at that as folklore and traditional ecological knowledge, because it goes way back. People have been saying this for a long time. Good observational knowledge. Shakespeare wrote about it in Venus and Adonis. Like a red morn that ever yet betokened wreck to the seamen, tempest to the field, sorrow to the shepherds, woe unto the birds, gusts and foul flaws to herdmen and to herds. And way before that, in the Bible, it was recorded, when in evening you say it will be fair weather, for the sky is red, and in the morning it will be foul weather today, for the sky is red and lowering. So that's just observation. The science behind it is the red can indicate more water content in the atmosphere. For example, a high pressure system has already passed and there's a low moving through. So there is reality to this ecological knowledge. Now, here's another fun one. More lore to amaze your friends. You can estimate ambient temperature based on cricket chirps. Yes, indeed. In 1897, Amos Dolber published The Cricket as a Thermometer and noted the correlation between ambient temperature and the rate at which crickets chirp. You count the number of chirps in 14 seconds and then add 40 to get the ambient temperature. Now, this is based on the snowy tree cricket. Field crickets are not as reliably correlated to temperature, but let's try it. So here's a snowy tree cricket, and I'm going to play this for it's 14 seconds long. count the number of chirps. I hope you can hear it. I'll run it through once, and then Soraya or Alex, let me know for sure that people heard it. What did people get? I got about 26, 27 chirps. And if you did, you add that to 40, that's about 67. And that recording was at 65 degrees Fahrenheit. So it really did work. You can Google that and play a bunch of sound bites that show it correlates to temperature. Is really fun. Okay, remember those symbols. So this is a classic weather station symbol chart. This is what we used to use when we wrote weather by hand, and weather was checked by human beings instead of computers back in the day. And we used something called the Stevenson screen to house all the instruments. My dad actually built me one when I was 8 years old. So when I say I was reaching back my inner geek to my 8-year-old, this is why. And you would check the weather every day at 4 p.m. and record it in your field notebook. And you would use these symbols in the notebook to record the weather. And this is really complicated. But basically, the circle in the center is the cloud cover. And then there's the little feather going off to the right. It would go wherever the wind direction is. So that's the wind direction and then the wind speed. And then the things grouped around it. There's at the very top, the letter I is indicating that's the type of cloud, that symbol. You can see the cloud types. They all have symbols. And you would put temperature, barometric pressure, weather conditions, etc. So that's how we used to do weather. And I've sort of adapted that in my journals. So I put in the symbol for the wind direction and speed and the cloud cover, and then the cloud symbols. And I'll also put in, various other things too, just depending on what information I have handy. So you can also estimate wind speed. If you don't have an anemometer, you can estimate it using this chart. I've included all of these charts, and anything useful like this, you're going to have in a download. So Alex or both of you, Alex and Soraya, can put the link now in the chat. You'll be able to download how to get all these. And I'll also be putting this in the web page, so don't worry about it now about getting too crazy about grabbing it. But this is a great way to tell what the wind speed is based on observable phenomena. So you can learn these. And then wind direction, literally there's so many different ways you can do this, depending on how sometimes it's like really clear. But if it's not really clear, you can literally just use your face, close your eyes and see if you can tell when the pressure changes on your face. Do the old lick your finger thing, but don't forget it has to be the whole thing. So when you hold it up and you can feel where the cooling is, it has to be all the way around. Carry a piece of string in your field kit, lightweight, and then dangle it from a stick or just hold it. Or if you're by a body of water, look for the ripples or put a pan of water out. So there's some great tools, some inexpensive, some not. This will read the barometric pressure. You can clip it on your field bag, your backpack. It's $20. It's a barometer, altimeter, thermometer. So you can use it for forecasting and recording your weather, your metadata in your field notebook. A little bit more pricey, and I actually recently got one of these for my upcoming birthday. My husband was very, very sweet, got me a this Kestrel, which has an anemometer, so it tells the wind speed. And it's got everything, so many other things in there. It's got barometric pressure, it reads dew point, all sorts of things. Wonderful tool to have in your field bag. And then I put all these other charts in there too. You can cut these out and print them out, put them in your journals as well. This is a great heat index for telling, you know, at what point temperature really gets dangerous. Likewise, this is a wind chill chart. I'm not going to go into these, but just letting you know, these are things you can print out, put in your journals. So you have lots more metadata. So when you figure out that wind speed, and it's 15 miles an hour, and you go up across the top, and it's 30 degrees, your wind chill's 19 degrees. So that's significant. All these are in the materials I sent you, but these are just great online resources where you can learn so much more. The Jetstream online school for weather is fantastic. That's a NOAA, National Weather Service, and then NOAA and NASA have Cloud Chart. The International Cloud Atlas is part of the World Meteorological Organization. There's that link there. My favorite is the Cloud Appreciation Society, which is based in England, but it's global. And you can actually join, and I'm going to share something from them shortly. And then there's a great resource for teachers called What's This Cloud? And they have a free PDF and lesson plans. In addition, I think Kathy Ballman is on this workshop. She's taking this certification for teachers. It's part of a citizen science for kids, learning how to identify clouds and then putting them into an app so it's global information. Super cool NASA project. And then I had to throw this in, right? This was, I just forgot who sent it to me. I hope you're on the workshop. One of our attendees said he had just discovered the cyanometer. And I did some research, and it was in 1789, Horace Benedict de Saussure created the cyanometer, cyan being blue, using 53 tints and shades of Prussian blue. He wanted to be able to hold it up like the photo there and then say, oh, the sky's number 16 blue. And he studied this for years, and he was trying to answer why the sky was blue. He actually wasn't the one who finally figured it out, but you could still create your own cyanometer and play with it to give yourself an idea of what color the sky is today, and put that in your field book. So I put that link there as well. So that's fun. All right, I'm going to play this here. Hopefully the sound will be, the sound is just music, so we don't have to worry about that. Check this out. You can order a cloud selector, and if you join the Cloud Appreciation Society, you get one. How cool is that? I just had to share it. I joined and I'm going to get one, so I'm all excited. The nerd in me definitely came out. All right, So now we're going to transition to, we'll take some Q&A and then we'll transition to how to depict clouds in our notebooks and how to make some cloud charts. So, okay, I lost my window. There we are. All right, so I'll go with Alex first. Are there some questions? Any questions? I know there's a lot in the chat, so anything that I can cover right now. Oh, I don't have your voice. Let's see. I'm not hearing you. Nope. Oh no, Soraya's gonna have to step in. Sorry, Alex, see if you can fix that. Soraya, can you pop in with some questions, please?
Yeah, one of the questions we had came from Marilyn French St. George, and she asked if the cyanometer can be used to compare air quality and haze by comparing color on horizon versus vertically.
Wow, I have no idea. I believe that's a really good question, and I would Google that. But my feeling is no. You would need a calibrated something calibrated to air quality index. So you might look at your local environmental, like EPA, might have a way to gauge air quality. That's completely different than I think that is. But that's a great question. Alex, are you able to talk yet? No, what happened to Alex's sound?
Okay, I think I fixed it.
Okay, yes.
There's a question from Rosemary, I'm sorry, I can't pronounce your last name, that says, how do you get your latitude and longitude where you are?
Yes, so that was the apps I talked about. So you can either use a dedicated altimeter, it's called, that's an instrument. The Kestrel instrument that I have has an altimeter in it as well. So that will tell me that, oh gosh, I'm talking about elevation, sorry. It also has the latitude and longitude. I was completely answering the wrong thing for you. So not an altimeter, but you want a GPS unit, a global positioning. So you're going to need something, either a standalone GPS unit or your phone. I mean, most phones, if it's GPS enabled, you can look it up right on there. And that was the app Gaia GPS is really good for phones. Sorry, I was like going off on the wrong track. Soraya, you have a question you want to pull out?
I do. This is from Deborah Kahn, and she asked, how can you tell if barometric pressure is rising or lowering? And the second part of the question is, how often and for how long must you watch the barometer?
No, that's a really, really good question. So for one thing, if you're out in the field, so you're on a trip and you're writing it in your notebook every day, then you're going to see the trend, whether it's falling or rising. So I'm showing, let's see. So here, I don't know if I can get this close enough. The Kestrel is showing me that your instruments like this will tell you the trend. So that arrow means it's been stable. So the over the last few days. If it was going up, there would be an up arrow, or down, there would be a down arrow. So you do need either an instrument for that you need an instrument to read the barometric pressure, and then you need to just observe, or you have a fun thing to observe for you. Alex, do you have a question? Oh, it didn't work again. There you go.
Oh, sorry.
You're flopping back and forth, yeah.
I didn't see any, but if I missed someone, please just speak out and I'll.
Okay. Ryan, did you have any others? There's a lot of chat.
There is, and there was a comment earlier in the chat from Angela. I'm gonna probably mispronounce her last name, Nicely Marple. She's from the UK. And when we were talking about noctilucent clouds, she actually mentioned that there is a specific time in the UK that astronomers actually look for them in the summer, and it's right about now. And she said that it's 1.5 hours to 2 hours post sunset and pre sunrise. And she tweeted a picture at you that she found of some of the noctilucent sun or clouds. So that would be interesting to share with people.
Okay. Don't know if she could put it in the chat or not, because I won't be able to access any social media stuff, but nice. I can put that on our website when I get this on the recording. So when I get, okay. Well, let's jump over to playing with creating clouds and cloud charts, unless we have, and just you guys pop in with questions.
A few questions did pop up.
Oh, okay.
Olivia Carey wants to know, what about sun and moon charts for when you're away from cell range?
Absolutely. I have one in my journal, but it doesn't give me the exact times. I'm sure you could find one. That's a good thing to look for. If you find one, Olivia, let me know. It would have to be, I think almanacs have, like farmers' almanacs and stuff. You have to carry a big book. I don't know if they put it into an app now. That would be fun. So that's something to check out on that. Let's see. I'm going to switch my view while you guys keep looking for questions.
I think Alex might have one.
There's a question from Beth Dryo that says, can taking soil temperatures be of use to determine highs and lows?
Ooh, that is a really good question that I don't know the answer to. Soils, certainly the ground retains heat. So I think that's a possibility for sure. What I'm showing you now is, in my journal, I keep reference charts at the front, and things like, here's the Beaufort scale, and just checking, make sure that's in the Beaufort scale. This is an old cloud chart that I did a lot more cartoony clouds. So I could remember, there's when I was learning what they all meant, what the symbols were. So, and I did a really simple moon phase chart, but of course it doesn't have the moonrise, moonset times. But if you know where you are in the cycle, you can at least tell whether you're waxing, waning, are you heading toward the last quarter or so forth. So those, I sent you a lot of charts you can print out and download. But what we're going to do is hopefully create a cloud chart for your notebook. So, but first we're going to look at the different types of blues and kind of what their properties are, because that's going to help us. Oops, sorry, view of my arm there. Help us when we create skies in our journal. So let's look at some of the blues. So I created a cloud and sky palette and with some of the blues that make really nice sky. And we're going to, I need to freshen the paint. When you use dried paint, it's always a good idea to spray a little water in. And let me show you what the different properties are of the blues. And you can see why we choose what we do. So I'm going to start with one of my favorite primary blue, which is manganese blue. It's very cool, very beautiful blue. Why is this not? Okay, better make sure my camera's having some focus problems. Okay. And then let's look at, so that's called Manganese Blue by Old Holland. And then let's compare that to a cyan blue from Greenleaf and Blueberry. And we're going to look at some properties in a moment here. I'm going to need to pause and look at why this camera is not staying focused. It was working earlier. So hold on. Let me know if there's any questions while I fuss with this. So any questions?
No questions so far.
Okay.
One question popped up. What was the name of the green leaf and blueberry color again?
It's just cyan. Okay, let's see if that does any better. Okay, now let's compare that to, so now this is a Daniel Smith cerulean blue. Oop, got too much water in there, so it's really shiny. Oop. There's a better representation of that. And then let's compare that to cobalt. You see how they are very different, aren't they? And then French ultramarine, which is a really popular sky colored blue. And also just for comparison, and these are Daniel Smith colors. This is a phthalo blue, the PTHALO. Very beautiful, dense blue. Now, these are all really popular, good colors for doing skies based on what you wanted to get out of what your sky you wanted to depict. So this is the phthalo and these are fairly cool blues. This blue here, the cobalt, I'm going to label these for you. So this is phthalo. This is cobalt. Nope, sorry, French ultramarine. And there's your cobalt. And this is the cerulean. And this is the cyan from Greenleaf and Blueberry. And then that is manganese blue from Old Holland. So wide range of blues here. And of course, if you water them down quite a bit, they're going to be a lot paler, and you can get a lot of different effects that way. So let's look at now properties of how these behave when you want to, say, lift clouds out of them. Now we're going to get a Kleenex to lift, and I'm going to play with lifting. I'm going to start with the cobalt, which is a nice sky color. And I'm going to create a puddle of the cobalt. Don't want it to be super dark, but get a decent amount of pigment. And then I'm going to lift clouds out of it. That is one of the easiest ways to create clouds. And if you'll notice, when you're doing skies, they tend to get paler toward the horizon. So darker in the top. So I'm trying to do like a graded wash here. And while it's still damp, you ball up your, just going to do one cloud here. You ball up your tissue and lift it out. And that's why I say when we want paint that lifts rather than stains. And I'll show you in a minute what a staining paint does. Now, it's funny, it's really, there was something on the paper here. I don't know what it is. There's literally, I think it might be oils or something, maybe from my hand, but that pigment went in and stayed. I can't lift that out. That's interesting. So you can also re-wet with clean water. I'm going to use a water brush. You can re-wet and try to lift more out. So lifting paints do that. So we can get a pretty white cloud out of that. And then here's the fun tip here. I've got some shadow violet you can use, which is a ready-made gray. I'm not real fond of shadow violet myself. I just take my blue, whatever blue I'm working with, so cobalt, and add a little bit of burnt sienna. Oops, that was too much. To get a really nice gray that complements that nicely. So this is going to be a cumulus cloud. And so I'm going to give it a little gray at the bottom. I'm re-wetting it with clean water. And I'm going to drop that in so it spreads, so it's nice and wet. And look at that. That makes a nice puffy, instantly has dimension cloud. So that's a really fun way to do it. Let's look at what happens with phthalo blue. Now, you can lift phthalo blue when it's still wet, but once it's dry, it's on the paper forever. But it's a gorgeous color. So there's phthalo, and I can do a capture here. And boy, it comes out really quickly. And then I'm going to let it dry, though. But see, that instantly makes some really great. So we could do, there's other clouds as well. And there you get some cloud action going. I'm going to let that dry though, so I can show you what happens when it's dry. So the other color that's interesting to look at for this type is French ultramarine. It's it's a popular sky color, but I don't find its lifting is as clear. I love how it's grainy and beautiful, makes gorgeous gray color. And when you're using your tissues, be sure you use a clean part. You don't want to add color accidentally. See, that just doesn't lift very well, even though it's still damp. If I get it wet, can I get any more out of it? I really have to push hard. So that would be okay if you're using French ultramarine. If you wanted to do just maybe we're doing the stratus clouds, because they don't need to be as optic white. So let's turn this into. So that's more of a stratusy cloud, right? But you can see they start really looking like clouds quickly. Now, let's look at this cyan here, or excuse me, phthalo, which is a type of cyan. I'm rewetting it, and it's not coming off. It's not going anywhere. So now remember how to add shadow and put clean water. And now I'm dropping in some of the gray to make that darker. And then you get some really pretty clouds. I'm really liking the way the cobalt looks. It's really pretty. So that's a really fun, quick way to make clouds in little landscapes for your journals, your field notebooks. Let's look at a couple other ways to do it, though. Any questions so far?
Roseanne, there was a question asking what brand of travel palette you are using.
Oh,
From Liam.
I will. I'll have to look that up.
That looks like a Schminky to me.
Somebody know Schminky? Yes, thank you. Whoever said that, go ahead and say that again, and then you can write that in the chat. The Schminky. Somebody can figure out how to spell that. Okay. Another fun. Okay, so let's say we want to start working on our cloud chart. So I created using this as my base, or my like index, if you will. Whoop. I liked how this showed the high, middle, low. It gave the altitudes and then pictorial representations of the different clouds. So I sort of use this as my basis for the cloud chart. So this is, but I did mine vertical because that's what my journal is. So this is what I came up with. This was actually really, really involved and fairly difficult to do because I wanted a fairly smooth wash. And boy, working, trying to get all these clouds in there at the right time was difficult. So I used a few tips. One of it is to use wax crayons to reserve your clouds. And the other is you can use wax paper. So let me show you how that works. I'm just going to kind of start out this one. And I have to sketch in kind of the basis. I can't wing it because it's a chart and I don't want to wing it because I might run out of space and I want to plan what I'm doing. So if I'm building the chart, well, I would start by using my pen. Actually, I will start with pencil because I don't want to have to worry about the ink drying. And I would use a ruler, but I'm also going to just freehand this. So that's where I want to put my title. And then I want to leave room here for the high, mid, and low. And I'll ink this in later, and I would use a ruler to ink it in. Now, there's 2 marks I want to make of the elevation, altitudes. Let me push my stuff a little bit farther up here. There we go. Even more. I just blorked on my, I must have had blue on my hand. So let's hope that's a lifting blue. It is, yay. Okay, so this is not to scale, right? Because this says 6,500 feet, 20,000, 42. So that's okay because I need to stuff a lot more into the lower. So I'm gonna, you'll just have to know it's you're not doing this to scale. And like so. Does that give me enough room? Actually, I don't need that much space for the, I can bring this one down a little bit because I'm going to have a little bit more up here, I think. Okay, so there's our gradations. And then I'm going to use a photo blue pencil to just remind me where I want to put my clouds. So we're going to start our, like I did here, I think I'm going to shove my cumulonimbus way over to the left. And then we'll have that anvil shape as well, just to give me enough room. Now you could do yours horizontal, do yours any way you want. But this is just to remind me kind of where I'm going to place it. Otherwise, I'll just forget. And you can barely see that. Yeah. I don't want to make it too strong, so just trust me that it's there. And then let me just show you, we're going to do this cirrus. I'm not going to get all the way through this because this took hours to do. You have to go slow and take your time on it so you get a really nice wash. Now I am pre-loading the cirrocumulus here again because I want to show you how I'm going to do that. So I need a little basis. And then the cirrostratus I'll do a different way. Okay, so to show you how to do, I'm doing that. I get the best results. So you can use these, you can buy these fancy wax crayons from art stores. They're called wax resist sticks. And you can use them. I find them a little gloppy. Maybe it's because I'm in the desert Southwest and it's warm and they tend to be gloopy. And they're good for some things, I'll show you. You can also raid your children's or your grandchildren's crayon boxes and use white crayons. They're super cheap. That's another good one too. So, but I'll show you, my favorite is to use wax paper. I mark the top so the waxy part's on the bottom. And then using a dull pencil, that's important. I literally color in over where I want the resist to go. So when I paint the wash, it's going to stay white. Now these are alto cirrocumulus. They're in not alto, excuse me. These are high cirrus cumulus, so cirrocumulus. They're high, so you're not going to see a lot of shadow. So I'm actually not going to put any gray in these. They're just too high. You're seeing them far away. Got to press pretty hard and make sure that wax gets down there if you want it to stay nice and white. And I feel like I can get a nicer pattern with wax paper than I can with, make those a little irregular. Those are a little bit too roundy. Okay. And then the other one I want to do is, we've got the Cirro Stratus. Now that's where the wax comes in really good. So I'm just going to lay a somewhat broken wax across there, like that. And then I'm going to go ahead and do a wash here, because I would probably do this in thirds and keep my wash growing, and if I tried to do it all at once, you're just going to get a mess. So let's get paint here. I'm going to go ahead and use the cobalt. And I'm only going to do the top third this time. And hopefully I got that wax down so it'll work well. So you'll be able to see. And I'm not going to make it super dark. Your sky is darker at the top and it's going to fade as it goes down, but I'd rather do it all fairly light right now, and then I can go back and add more color after it's dry, a wash to darken the top. That works a lot better than trying to make it all dark and then I end up not continuing well. So this is, let me test that. Yeah. There we go. And I'm reserving my cumulus here, or the anvil. And then I think I'm going to, I got a little, probably a little too much in here. I can pick up just a little. Oh, but I like that. Okay. Oops. And I can see here. So I'm going to have a weird streak there, but that's okay. So that's how I would go about creating this. Next, I would do my alto stratus here, alto cumulus, and so on. This guy I can leave pretty to last and then fill it in as I go. And I can soften these edges, for example, because this is a nice lifting paint. I can soften those edges so it's not so sharp. So I can do it last though. and go in and add shadow and things. And I would want to go in down here and paint I'm going to paint a little mountain scene. And so I have something to anchor the storm zone, which is always fun. So, maybe I'll go in and just do some random mountain hills. I'm leaving a space so I can put some fog around it. Okay, that's just to give me a basis for that so I don't forget. But for example, when I do the Nimbus Stratus, I'm gonna place this so the rain goes in front of this hill and behind this hill. That way the clouds will look like they're in different places. I messed up here. This rain should have come all the way down, but that's okay. And then I went in after I was finished and labeled them and put the cloud symbols so I can remember where everything is. So I would continue to do that on there. And then remember when you want to add the gray to make your lovely cumulus, we do so, you wet it first. And I would probably wait till last for that, but I'm going to show you now. Now I'm going to pull some cobalt and create some nice gray. Oops. There's a really pretty gray. And let's give this a gray belly. And I never take the gray to the full edge because you kind of want them to look like they're luminous on the sides, remember. So you would just keep playing with that to create until you like what it looks like. See, that's already looking really pretty, but let it dry and then keep adding. It's easier to add than to take away. So that's how you would build this up. And then of course, very little in here because that's a blowout there. So that's how we would do that. I want to show you one other way to do this though. So you have time. And that is, I thought, well, why don't I try a different way, something a little easier. And that is painting directly and using gouache on toned paper. It's tons of fun because you don't have to angst over, am I going to reserve my clouds correctly and accidentally, wipe out a cloud and then getting a nice wash. It took me several tries to get this wash to where I liked it. So, this is definitely not super easy to do, but using gouache is much easier, and you can see how quickly you can get. Let me show you. Any questions so far?
Roseanne, we have a question from Lowell Thornhill, who says, what brush is being used? The bristles look really flexible.
This one here? Well, I can just say this one is a Da Vinci travel brush. These are travel brushes. This is a Isabay squirrel mop brush. And again, it's a travel brush. And then well, this is just an inexpensive $8 Pentel water brush. And I do like flexible. Let's see. Let me get my gouache. So I keep my gouache in the tube. I don't like dry gouache. I squirt out when I want to use it. I don't use it very frequently, but it's great for clouds. So let's do a puddle of white.
Roseanne?
Yeah.
We did have one more quick question. Carol wanted to know, how does gouache compare to using acrylics?
I don't know. I don't use acrylics. I've never tried. So that would be, I would have to look that up.
I can answer that in the chat,
please.
actually.
Oh, go ahead and answer it verbally so everyone can hear, because I'm just getting set up here.
So gouache actually acts more like watercolors compared to acrylics. It's opaque watercolor, as someone just did mention in the chat, whereas acrylics are plastics made into paints. And they're not, while they are a water medium technically, they are not as flexible as gouache is, and they can't be manipulated as easily, but they don't wash off of things. They're permanent. And
got it.
Yeah, they will ruin your travel brushes if you don't wash them out immediately.
Ooh.
So
that's horrible.
That's something you want to keep in mind. So that's a quick rundown of the differences.
You
can't re-wet acrylics.
Okay. I apparently can't talk and squeeze out paint at the same time. So I just almost squeezed out the wrong color. So on the gouache is, as Sarah said, it's opaque watercolor, and it has is the filler a chalk, so it turns it it's not transparent, you can't see through it, so it's great for layering. It's great on toned paper. So say I want to do our chart like this, you just do it direct. I don't have to worry about reserving anything, and I can go back. I can start out light. I can make it darker. I can do my little cirrus. I'm here, whoosh, swoosh there, and really make some pretty clouds. I really should have clean water, so I'm being very cautious here. Swoosh, loose. I also have dirty fingers, worried I'm going to contaminate it. And if I keep it pretty dry, then I can get that wispy shape. It's a dry brush. I don't want a lot of water on it. So let's do that. Let's do what are those, cirrocumulus? So you can do your kind of random shapes here, but remember that they tend to make patterns up there that high. So they're somewhat even in general, exceptions to everything. But I just want to get these down here so you can see how I add the shadow as well. Let's do the Nimbo. What is that one called? The Nimbo Stratus down here. A little bit more, I just a little too dry there. There we go. Trying to make the edges a little fuzzy, but you can also re-wet gouache and move it around a little. I'm trying to keep it somewhat irregular. Now, on my gouache, I just use this great Caran d'Ache set that has burnt sienna, yellow, white, blue, and red. I never use the black. I create my own by color mixing. So I mix the blue and the burnt sienna to make a really pretty gray. I used way too much here, so let's pull that out. There's a nice gray there. So I would just drop this gray. Let's make this into a nimbus cloud, right? It's precipitation. Just drop it right on. Even if it's still damp, that's actually good. It'll blend in better. And I'm going to get a cleanish brush and blend it. There. So suddenly it looks more like a cloud, and then I could even pull some here and start creating, you know, the rain. You can have it be uneven. You can make it a big sheet of rain. Oops. You can make it go behind or in front of something. So if we wanted to do the fog, we would you would have your, for example, if we've got a landform, and then if we wanted to do fog, we would, let's see, I think I want that. Get a fairly wet gouache, and we can lay it in like behind and in front of part of our landscape. So then you would have your like, I think it's got your low clouds. So it's a lot easier to work with, and it just gives a different look than your traditional watercolor. So this is going to be fun. We can fill in all the various parts and not have to angst over the blue. But it is a really good exercise to do this too. So you can see this is looking really nice here. And I can continue, I can wet this edge and blend it in as I go. Actually, I would put my stratus cloud there, alto stratus there, and then my alto cumulus, and build those in, and then go back and label. This is a pretty light paper. This is like 90 pounds. So I don't have a lot of the heavy, like 130 pound, but that would behave better. But when I'm finished, it's going in my journal. It's going to get flattened anyway. So that is how I would do that. So let's go to questions, and then we'll be wrapping up. So let me switch cameras. All right, there we go. We can feel free to turn your videos back on, and we can take questions. So we can take questions from chat, or feel free to just say a question as well. I know the chat's probably getting hard to manage, isn't it, guys?
Yeah, it'll be a little difficult. We can suggests that people raise their hand by using the reactions as well.
Okay. I just saw a question. I just happened to look over and see one. Can you talk about how you add this paper to your journal? Okay, there's several ways you can do this. Now, I am going to switch back to my overhead camera here so that you can see. Just throwing things out of the way here. My journal is set up so it's a leather cover. Here. It's a leather cover. This is old. This is probably 25 years old. And it's very simple. I lace the paper in three-hold 9x6 paper. I lace it in with just shoelace so I can get a nice flat. Hey, Alex, look at this. Look what I got. I had to show Alex this. He came to my Mars virtual food trip. Yeah, I ordered a Mars Perseverance sticker and a coffee mug. Sorry. Okay, so you can see it lays flat. And then I can take it out, the paper. When I'm done, I archive my journals in 3-ring binders, like so. So you can, and then I index them. So I've got dozens and dozens of these. So I just put 3 holes in my charts and I lace it into the front. Now, if you want to do this in a journal that isn't like mine and isn't replaceable, you just grab, here's a toned paper journal. You can, one tip would be take a straight razor and, excuse me, and slice out, say this is the front of your journal. Put something behind it. Slice the page that you want, you're going to actually create. Oops, there I had 2 pages, but that's fine, because you could do several things. And then glue, where's my, glue that in. And maybe you use rubber cement or something so that it can be peeled off. This is smaller than my normal size, but that's one way to do it. Then you can take it out and put it into your next journal. Or you could use, what are those paper, those metal things with prongs that you push through, and then, what are those called? To do that. So that's one way to do it on a journal that has a standard binding. So I hope that answered the question. Just go ahead and ask any other questions.
Olivia Carey has a question. Olivia, you can go ahead and unmute yourself and ask your question.
Okay, I was going to ask what toned paper you used, and you briefly flashed the front.
Oh, so this, good question. This is not the paper I did the demo on, and I'll show you why. This is Strathmore, what's the 80 pound. And I started to do it on this, and it just yucky. It just didn't work well. See how it got really wobbly. So I ordered Strathmore paper. This is like 100 and at least 130 pound. And I cut it to size. It was bigger. This is really pretty thick. See how, and it stands up really well to lots of water. So that's
Okay,
what I was. Sure. Any other questions?
Katie Iverson wanted to know what dimensions the pages in your journal are.
Yes, those are 9x6. And I order, my paper is B paper, it's BEE. It's 90 pound, and I like the tooth on it because it takes ink really nicely. So I do a lot of writing as well as painting. This is a lot of paint, and it did pretty well. That's not bad for 90-pound paper. I could still use the back if I wanted. So yeah, B paper is getting really hard to find. Speedball makes them really nice in the 90 as well. So that's another good one. I don't know why B paper is just getting impossible to find. So. All right. Anyone going to go out and make a cloud chart? Yeah? No?
Lots of yeses from the chat.
Good. Okay, because it's really fun. And I hope you'll go out and start paying attention to the weather and what's changing. And when you get weather coming in, go out and notice what the birds are doing. Take notes. Go back, and then over time you're going to learn what the cute clues are for weather in your area. You know, I can't give a full rundown for every area on the planet. We've got people from all over, so you're going to learn your area. That's the whole point with that. So great. Well, this was fun. So Soraya, I'm actually going to share my screen one more time. And then Soraya is going to, actually, I completely lost it. So nope, I won't be able to. So Soraya is going to drop in the chat. This was a free workshop, and we do ask so we can continue to do this. If you really enjoyed it, I do have a donation tip jar, and she's going to put that in the chat. It's exploringoverland.com/tip jar. I had a screen to put up, and it
just popped it in.
It disappeared on me. So I hope everybody had fun, and I will put all these resources on a web page with all the downloadable, printoutable things, and I hope you'll do that. And please send me what you create. Create your own cloud chart. Put your own landscape at the bottom. One of mine had saguaro cactuses at the bottom, but so that's always fun to do. So thank you all for joining, and I hope you have a great rest of the weekend. And I'm hoping for some weather coming up soon in Tucson. I keep checking my dew point to see when the monsoons are coming. Oh, not quite yet, Soraya.
Always hoping.
Yeah.
All right. Thank you all. The
everyone.
tip jar link is in the chat, so please add what you can.
Yeah, anything helps. It really does. Thank you so much, everybody.
Roseanne.
Yes,
there was a question. Someone asked if there was a way to contribute without using Google or something like that.
Let's see. It's a secure Stripe.
Yeah, that was me, and I don't have a Google Pay anything. I have something like PayPal.
Oh, how strange! It's supposed to be just Stripe. It's a or Square, something like that. It's not Google Pay. I don't use that. So yeah,
that's what showed up on the website. It says Google Pay.
What? Okay, that's new to me.
I think if you just put your information below that, I believe that's just one of the ways that you can pay, because that's where I keep my stuff stored. So I just pressed on it. But if you put your information below that, I think it will work.
Okay, I'll try that. Thank you.
Thank you. And then I do have PayPal. I can send you that info too. Thank you. Great.
Thank you so much, Roseanne.
It was fun. I'm sorry I couldn't see everybody. There were so many people. You're all just like this big. Hi, Susan. Everybody. So I hope everyone's doing well. Your journaling's going well. Good. And send me your examples. I always love to see that. Alex, thank you. Soraya, thank you. Thanks so much. There was a ton of activity in the chat. Oh my gosh. I'm so glad you were there, Alex, too.
Yes, there was. Thank you, Alex.
Yeah. Wow. Thank you.
Thank you, everybody. Bye.
Have a great weekend. Bye.